In today's lesson, we are looking at scatter plots and looking for linear correlations in our scatter plots. So the idea of a scatter plot is you're collecting some data and we're graphing it. And then once you have a graph, you're looking for correlation. So if you look at this first graph, notice how it's a perfect straight line. So a perfect positive correlation versus a perfect negative correlation. And then we're looking, okay, strong, weak, no correlation, weak, strong. So positive, the second graph. Yeah, I mean, it's a pretty good linear correlation. As you can see, it's just not a perfect straight line. This next one, if I'm drawing a line in the middle, it's still a little bit of a correlation, but it's just not as strong. This last one, there's like no correlation. It doesn't look like the variables are increasing together in a linear fashion at all. And then these ones, same idea, except it's negative. So it could be negative, but still a strong correlation. Negative just simply means it's decreasing. Now, correlation, we actually attach a value to that word, which is called the correlation coefficient, and that comes from R. So if you have a perfect positive correlation, we're going to say that R is 1 versus R is -1. So correlation coefficient anywhere from -1 to +1. And then no correlation would be anything close to 0. So a strong positive correlation, that might be an R value of, let's say, 0.98. That's pretty strong. A weak one, maybe that's R equals 0.5. And then negative, it could still be a good correlation, but it's just in the negative direction. Negative 0.5, or R equals -0.98. So we've got strong correlation on both ends, and then a very weak correlation in the middle. All right, so here we have some data that we're going to graph. It says the table shows the percent of U.S. households with internet access. Okay, so when you're dealing with years, one thing you can do is we could say that the first year we're looking at is year 0. And then, so if 1997 is year 0, 2000 is 3 years after. And then I've got 4 years after, 6 years after, and 10 years after. So when we go to label our graph, I've got X and Y. X-axis represents years. And I need to go 0 to 10. So 1, 2, 3, 4, 6, 8, 10. All right, and then Y-axis, this is going to be percentage. So on here, the highest number is 60. So let's count like this: 10, 20, 30, 40, 50, 60. So that last point will go off the graph just a little bit. All right, so let's estimate about where these points are. So 0, 18, it's going to be about here. All right, over 3 up 41.5. Over 4 up 50.4. Over 6 up 54.7. And then over 10 up 61. Okay, so normally a really good scatter plot is going to have a lot of information to look for correlation. We don't have a lot. So it's just going to be an estimation. It's not going to be perfect, but just to kind of get the idea. We want to draw a line that goes through our data. So a line of best fit. So we're just going to eyeball it. And there's, a lot of variation on where you put your line. So we're just estimating. You always want to pick, I usually say like 2 points. So let's say I'm picking these 2 points and I'm going to connect them. So this is an estimation showing how our values are correlating with each other, how they're increasing. So now I'm going to write an equation of the line that I drew. So if I'm going to write an equation, let's first write what those 2 points are. So I put a line through the point 3, 41.5. So this one. And then the other point is 10, 61.7. This one right here. So how do I write an equation? I'm going to first find my slope. Subtract my y values. So 61.7 minus 41.5. And then subtract my x values, 10 minus 3. So when we're doing this, it is okay. We're just going to get some decimals and we will just round them. So this will be 20.2 over 7. If you divide that, we're going to round it to about 2.89. So there's my slope. Now let's go to point slope form. So y minus y1 equals m times x minus x1. So if I use my first point, I'll have y minus the y value, 41.5, equals m 2.89 times x minus the x value, 3. And then do what we've been practicing is now get point slope form to slope intercept form. So y minus 41.5 equals 2.89x minus 2.89 times 3 is about 8.67. And then if I add 41.5, I will get a final answer of y equals 2.89x plus 32.83. So this equation is estimating, it's describing how my values are changing. It's the equation of this line. Now, we make an equation, the whole purpose is to then make a prediction of the future. So the prediction, let's say we want to predict based on our data, what is the percent of that will have internet access in, let's say, 2020. So 2020 is how many years after our, 1997. It's 23 years. So what you can do is plug in 23 for x. So y equals 2.89 times 23 years later plus 32.83, and you should get 99.3%. So this is all just estimating and predicting. It's not perfect. In 2020, there's probably not that high of a percent with internet access, but that is the idea of just collecting information, estimating, making predictions. And obviously, if we had a lot more data points, you can come up with a better estimate. All right, so our next example is looking at life expectancy based on the year that you were born. So, similar idea, if we're dealing with these years, our first year could be 0. And then this would be how many years after the first year. So I've got 3, 10, 15, 20, and 26. Now, instead of drawing a scatter plot and estimating, we're going to use a graphing calculator, and we're going to input all of this information, and it will give us the best possible equation for making predictions. So grab a graphing calculator and follow along. We're going to hit the stat button and then enter. I have some information in here I'm going to clear. So I'm highlighting the list at the top and hitting clear, enter, to kind of clear out a whole list. So under L1, I'm going to input all of these X values. So all the X values on my table, 0, 3, 10, 15, 20, and 26. And then in L2, I'm going to put my Y values. And now once you have your data, you're going to hit stat again, go over to calc, and go down to the fourth one, linear regression, and hit enter. And now you're given all this information. Okay, if your calculator is not showing the R squared and the R, I can fix that in class. But for starters, let's just look at the A and the B. So they use A, I know we usually use M for slope, but they're giving the value for your slope, and they're giving the value for the y-intercept. So if we write that equation, y equals, so let's do 0.14. We're just going to round x plus 73.89. So there is the estimation for our data. It's estimating that best line of fit. So now if you look how it says R, remember we talked about R values at the beginning. This says 0.99, so that's positive, and it's a strong correlation. So without even graphing, I know that this data point, they're going to be increasing, and it's going to be pretty close to a strong linear correlation. And the very last part, we're making a prediction for people born in 2025. So we're going to plug our prediction in for X. 2025 is 45 years later. So let's use this 0.14 times 45 years after 1980 plus 73.89. And you should get that y equals 80.19. So the life expectancy would be about 80 years for people born in 2025. And it's all just estimating based on collecting information, explaining the information, and then making predictions on everything. So there is your lesson on scatter plots. Good luck.